Okay, and now for Thursday's work, your last of this particular chapter, and it's actually probably the easiest thing you'll do so far. If you look at the homework questions, I'll give you a couple to try, much simpler than yesterday's work. So anyways, hold on. Where'd my little marker go? Oh, there it is. Okay. So today, what we're going to do is we are going to do what's called selective precipitation. So selective precipitation is you have two insoluble salts that could form. So you basically have a solution of like two ions that are dissolved, usually with nitrates or perchlorates, something that's really, really soluble. They just throw two salts in solution, and then they do like a dropwise, usually with a solid, some small concentration of an ion that would precipitate both of them. But the two salts have different KSPs, and you have to say which KSP will precipitate first. So it's almost like it's a way of separating an ion out of solution by just making it precipitate, and you're drawing the ion right out of solution. So I'm going to I'll post the question here so you can see it. And this is, oh, that's Ruby. It's on page 652, and it's called selective precipitation, and it's example 16.7. So if you wanted to look at how they did it, I know I do things like a tad differently, but it should be relatively straightforward here. So we have a solution has 1.0 times 10 to the negative fourth molarity Cu plus 2 ion, and 2.0 times 10 to the negative third molarity Pb2 plus. Okay, a source of I minus is added to the solution. So the question is, will PBI2 with a KSP equal to 1.4 times 10 to the negative eighth? I don't need a bracket there. Or CUI with a KSP of 5.3 times 10 to the negative 12 precipitate first. And what is the concentration of I minus necessary to begin precipitation of each salt? So let me just diagram what this is going to look like. So here's your solution. You probably put copper and lead. You have these two ions kind of floating around in these solutions, and you're basically dropping in probably something like Ki into here. And what's going to happen is one of these two salts, CuI2, or sorry, is it plus one? Why does it say CuI? Sorry, it is plus one. Okay, CuI is, okay, so it's either going to be CuI is going to fall to the bottom first, or Pb plus 2 is going to fall to the bottom first. And that's what they're asking for. And then the calculation is actually really simple. Sometimes like on a multiple choice question, you might be able to guess if these had the same general formula, like it was PBI and CUI, and they gave you the different KSPs, you would just pick your lowest KSP. Like the lowest KSP is probably going to precipitate first. We don't know that exactly, but wouldn't it make sense? Like if you have a really low number, that means like the smallest bit of I is going to snap, make this precipitation occur, and then all this Ki is going to start, falling to the bottom. So my guess is it's probably this one. I'm not sure how that I2 is going to impact it. It might make it, but usually you can just go. Usually they make a big difference. Like they'll make this like 5.3 times 10 to the negative 20th, 1.4 times 10 to the negative 8th. And then you can decide, and it's pretty easy to pick, that the lowest KSP is usually the one that's going to precipitate first. But let's calculate it and see if we're right. I'm not 100%, I didn't look at the answer yet, so let's just see what our answers are. So we'd first start off and set up with our PBI2 goes to PBAQ plus I minus AQ. And then we have CUI, water. And that's going to get us Cu plus I minus. And so our KSP of this one is going to be PB plus 2. Sorry, and that's a 2I minus. So that's going to be I minus squared. And then this is KSP equals Cu plus... Oh, man, I feel like I have to have a plus 2 there. It's a plus and an I minus. And so those are our two expressions. We solve for each of them. So PBI2 will... I'm just going to erase this here. So PBI2 is going to be 1.4 times 10 to the negative 8th equals PB concentration is 2 times 10 to the negative 3rd, and then I squared. And this one's going to be 5.3 times 10 to the negative 12th equals 1 times 10 to the negative 4th times x. 1.4 times 10 to the negative 8th divided by 2 times 10 to the negative 3rd. And then square root it. So I got x to be 2.65 times 10 to the negative 3rd is my concentration of I minus needed. And then this one is 5.3 times 10 to the negative 12th divided by 1 times 10 to the negative 4th. And that one ends up being 5.3 times 10 to the negative 8th. And we sort of just figured it out that this I minus is going to precipitate this one. Just like we had predicted, the lowest KSP is usually going to give us our first precipitate. The numbers could mess you up a little bit, but for, that's what's going to happen. So what we would then say is, since our concentration of I minus here required is so low, this is lower than this one. So this one is lower than this one. Therefore, you need a smaller amount of I minus. Let me see if I can tilt this up down a little bit. So the answer is CUI will precipitate first. CUI will precipitate first because its I minus concentration required to precipitate is much lower than PBI2. than that one. Okay, and so you'll have a couple questions based on this. This is really not so bad. And by the way, the answer is like, what is the concentration of I- necessary to begin precipitation? Well, those are your two answers. So answer 1 and then answer 2. All right, good luck today.